Hello and welcome to the online class of Mathematics Standard 10. In the last class we discussed about algebra of number sequences. Now let's consider some number sequences. First one 2, 3, 5, 8, 12, etc. The sequence starts with number 2. 1 added to get the second term, 2 added to get the third term, 3 added to get the next term, and 4 added to get the next, and so on. Another sequence 1, 3, 7, 13, 21, etc. So what is the rule applied here? Sequence starts with 1, 2 added, 4 added, 6 added, then 8 added to form the terms of the sequence. Third sequence 2, 6, 10, 14, 18, and so on. First term 2, 4 added to get the second term, again 4 added to get the third term, 4 added again, and so on. Next one 0, 5, 10, 15, 20, etc. The number sequence starts with 0, 5 added to get the second term, again 5 added to get the third term, 5 added, again 5 added, and so on. Next one 6, 7, 10, 15, 22, etc. First number 6, 1 added to get the second term, 3 added, 5 added, 7 added, and so on. Another sequence 3, 5, 7, 9, 11, etc. First term 3, 2 added to get the next term, again 2 added again, and so on. We have two types of sequences here. Sequences starting with a number and different numbers added, and sequences starting with a number and a fixed number added repeatedly. So let's go through the sequences once again. And the first one, the first term is 2 and different numbers are added. Second one, the first number is 1, 2, 4, 6, 8, etc. are added. That means different numbers added. Third sequence starts with 2 and number 4 added repeatedly. The next sequence also a fixed number added repeatedly. That is 5 added repeatedly. Sequence starts with 0 and 5 added repeatedly. Next one starting with 6 and numbers 1, 3, 5, 7, etc. are added to form the sequence. That means different numbers are added. The last one starts with 3 and number 2 added repeatedly. So we are going to consider only those sequences starting with a number and a fixed number added repeatedly. So we have 3 such sequences here. The first one starts with 2 and number 4 added repeatedly. Next, starting with 0 and 5 added repeatedly. Last one, starting with 3 and the number 2 added repeatedly. So all these 3 sequences have a common rule applied. And what is that rule? All the sequences start with a fixed number and a constant number, a fixed number added repeatedly. Such sequences are called arithmetic sequences. Now how to define an arithmetic sequence? A sequence got by starting with any number and adding a fixed number repeatedly is called an arithmetic sequence. Now consider some examples for arithmetic sequence. 1, 2, 3, 4, 5, 6, 7. Natural number sequence or counting number sequence. It is an arithmetic sequence. Its first term is 1, and what is the number added repeatedly? 1 added repeatedly. The odd number sequence starting with 1 and 2 added repeatedly. Next, 2, 4, 6, 8, etc. The even number sequence starting with 2 and 2 added repeatedly. Next, 2, 7, 12, 17, etc. sequence starting with number 2 and 5 added repeatedly. 4, 8, 12, 16, 20, etc. multiples of 4. 4 is the first term and 4 added repeatedly. Now let's consider an arithmetic sequence. 1, 4, 7, 10, 13, 16, etc. Here the first term is 1 and number 3 added repeatedly to form the sequence. Since number 3 is added repeatedly, the difference between the consecutive terms of this sequence must be 3. Let's check it. Second term minus first term, x2 minus x1, 4 minus 1, 3, x3 minus x2, 3, x4 minus x3, that is also 3, x5 minus x4, 3, x6 minus x5 is 3. Since an arithmetic sequence starts with a number and a fixed number added repeatedly, we always get the difference between consecutive terms of the arithmetic sequence as a fixed number. Here the constant number added is 3, therefore the difference between the consecutive terms is always 3. So this is an important property of an arithmetic sequence. In any arithmetic sequence, if we find the difference between the consecutive terms, we must get a fixed number as the difference, and actually that number is the number we add repeatedly, and that number we add repeatedly in an arithmetic sequence is called its common difference. Why it is called common difference? Because the difference between the consecutive terms are the same, and we can use the letter D to indicate the common difference. Now, how to define the common difference? The constant difference got on subtracting from any term the term immediately preceding it is called the common difference. So what is the common difference of this sequence? The number 3 is added repeatedly. Therefore, the common difference is 3 here. Now let's consider a sequence 3, 6, 9, 12, 15, etc. Is it an arithmetic sequence? Let's check. This sequence starts with 3 and 3 added to get the second term 6. Again 6 plus 3 9, 9 plus 3 12, 12 plus 3 15, 15 plus 3 18, and so on. So here you can see that the sequence starts with 3 and number 3 added repeatedly. Therefore, this is an arithmetic sequence. What is the common difference? Common difference is the number we add repeatedly. Here that number is 3. Therefore, the common difference is 3 here. Now, one more sequence. 3, 9, 27, 81, etc. First term 3, second term 9, third term 27, fourth term 81, and so on. Let's check whether this sequence is an arithmetic sequence or not. For that, we are going to find the difference between the consecutive terms. First, second term minus first term, that is 9 minus 3, that difference is 6. Now third term minus second term. That difference is 18. So you can see that the differences are not equal. Therefore, this is not an arithmetic sequence. Now one more sequence. 10, 8, 6, 4, etc. Is it an arithmetic sequence? Let's check. The first term of the sequence is 10. 2 is subtracted to get the second term. Again 2 subtracted to get the third term, and so on. So here the sequence starts with 10 and 2 is subtracted repeatedly. Can it be considered as an arithmetic sequence? In an arithmetic sequence, we start with a number and a fixed number is added repeatedly. Here a fixed number is subtracted repeatedly. But we know that subtracting a number is same as adding the negative of that number. So here we can consider this sequence as a sequence starting with 10 and negative 2 added repeatedly. Therefore, this can also be considered as an arithmetic sequence because it starts with a number and a fixed number is added repeatedly. Here that fixed number is negative 2. Therefore, the common difference of this arithmetic sequence is negative 2. So you can calculate the common difference by subtracting first term from the second term. So on calculating, we get d equal to x2 minus x1 equal to 8 minus 10, that is negative 2. The common difference of this sequence is negative 2. So if you go to the terms, you can see that the numbers are in the decreasing order, and in such arithmetic sequence the common difference will be the negative of the number subtracted. Now we can consider some problems given in your textbook. First one. Look at these pictures. If the pattern is continued, do the number of colored squares form an arithmetic sequence? Give reasons. So in the first figure, you have a big square made using small green squares. How many small squares or green squares are there in it? You can count the number of squares. It is 8. Now in the next figure, what is the number of colored squares? It is 12. In the next figure, it is 16. Now what about the next figure? There you have 20 squares, small squares. So you can write the number of squares as a sequence: 8, 12, 16, 20, and so on. So is it an arithmetic sequence? You can see number 4 added repeatedly. So the difference between the consecutive terms of the sequence are equal. Therefore, it is an arithmetic sequence. What is the common difference then? What is the number added repeatedly? It is 4. Therefore, the common difference is 4. Now, the next question. See the pictures below. How many small squares are there in each rectangle? How many large squares? How many squares in all? Continuing this pattern, is each such sequence of numbers an arithmetic sequence? So let's consider the first one. How many small squares are there in each rectangle? So in the first rectangle, you have 2 small squares. In the second, you have 4 small squares, and in the next, you have 6 small squares. And in the fourth one, you have 8 small squares. So you can write the number of small squares as a sequence: 2, 4, 6, 8, etc. Is it an arithmetic sequence? It is an arithmetic sequence with common difference 2, because 2 is the number added repeatedly. Now, next question: how many large squares? In the first figure, you have 2 small squares but no large square. Therefore, number of large squares in the first figure is 0. Second figure, you have 4 small squares making a large square. Therefore, you have 1 large square in the second figure. The third one, first 2 columns make a large square. Second and third column make another large square. That means you have 2 squares in the third figure. The next figure, the first 2 columns make a large square, second and third make another large square, and third and fourth columns make another large square. That means you have 3 large squares in the figure. You can write the number of large squares as a sequence: 0, 1, 2, 3, and so on. This is an arithmetic sequence with common difference 1. Now, how many squares in all? So, to find the total number of squares in each picture, you have to add the corresponding terms of the 2 arithmetic sequences. That means number of squares in the first figure, 2 plus 0, 2. Number of squares in the second figure, 4 plus 1, 5. Number of squares in the third figure, 6 plus 2, 8. And next figure, number of squares, 8 plus 3, 11. The sequence is 2 plus 0, 2, 4 plus 1, 5, 6 plus 2, 8, 8 plus 3, 11. Is it an arithmetic sequence? The sequence starts with 2 and 3 added repeatedly. Therefore, this is an arithmetic sequence with common difference 3. Now, one more question. The algebraic expression of a sequence is xn equal to n cubed minus 6n square plus 13n minus 7. Is it an arithmetic sequence? So, you are given the algebraic expression or the nth term of a sequence. You have to check whether it is an arithmetic sequence or not. So, for that we have to form the sequence. You have to find the terms of the sequence. So, how to find the terms of a sequence from its nth term or its algebra? So, you know that the algebraic expression of a sequence is the relation between its terms and positions. So, that means if you substitute n equal to 1, 2, 3, 4, 5, etc. in this expression, you get the first term, second term, third term, and so on of the sequence. So, to find the first term, we can substitute n equal to 1 in the given expression. N equal to 1 means x1 equal to 1 cubed minus 6 into 1 square plus 13 into 1 minus 7. So, I have substituted n equal to 1 in the expression xn equal to n cubed minus 6n square plus 13n minus 7. So, simplifying, we get 1 cube is 1, 6 into 1 square is 6 into 1, that is 6, 13 into 1, 13 minus 7. Now, here you have 2 positive terms and 2 negative terms. I am adding the positive terms first. 1 plus 13 is 14, minus 6 plus minus 7 is minus 13. So, that is equal to 14 minus 13 equal to 1. Now 1 is the first term of this sequence. Now to get the second term, substitute n equal to 2. That is x2 equal to 2 cubed minus 6 into 2 square plus 13 into 2 minus 7. Simplifying, we have 2 cube 8, 6 into 2 square, that is 6 into 4 24, 13 into 2 26 minus 7. Again add the positive terms, 26 and 8 34, minus 24 and minus 7 minus 31 equal to 34 minus 31 gives 3. The second term of the sequence is 3. Now to get the third term, substitute n equal to 3. x3 equal to 3 cube minus 6 into 3 square plus 13 into 3 minus 7. Simplifying, we get 3 cube 27, 6 into 3 square, 6 into 9, 54, 13 into 3, 39 minus 7. Adding the positive terms 27 and 39, we get 66. Negative terms minus 54 and minus 7 gives minus 61. 66 minus 61 equal to 5. Now to get the fourth term, substitute n equal to 4 in the expression. That is x4 equal to 4 cube minus 6 into 4 square plus 13 into 4 minus 7 gives 64 minus 96 plus 52 minus 7. That is equal to 116 minus 103. That is equal to 13. 13 is the fourth term. Now you can write the sequence 1, 3, 5, 13, etc. So you have to check whether this sequence is an arithmetic sequence or not. So for that you can find the differences between the consecutive terms. First difference, x2 minus x1, second term minus first term. 3 minus 1, that is equal to 2. Now third term minus second term, 5 minus 3 equal to 2. Again find the difference between fourth term and the third term. 13 minus 5 equal to 8. You have the first two differences equal, but the third difference is not the same. Here the differences are not equal, therefore this is not an arithmetic sequence. That's all for today. See you in the next class. Thank you.